Hello everyone, it's a great pleasure meeting you all in my mathematics class. Today let me continue with finding the nth derivative of a mixed function like this ub using Leibinitz theorem. What does Leibinitz theorem states? dn, that is nth derivative of the compound function uv is equal to unv plus the nc1 n minus 1 v1 up to uvn. Here suffixes mean the derivative, that nth derivative. Un means nth derivative, un minus 1 means n minus 1th derivative. So this is Leibniz theorem. I have already explained about this in my earlier videos about what is Leibniz theorem and and I have also done the application of it for finding the nth derivative of a mixed function. Okay. Now let me continue with this so that you may be able to understand better and try to know better than what you have understood. So with that idea in my mind, I have taken two different problems which will make you to understand better. Before I take this, let me go ahead with this problem. Here you are asked to find the nth derivative of x squared e to the power of 5x. As say you can find that Leibniz theorem, you have got two functions u and v, and the differentiation has to be carried in the way of u and v plus nc1 un minus 1 v up to uvn. I will teach you, or I will explain how this exactly applied to this particular, that is how Leibniz theorem is directly applied here. Now you take this u as e to the power of v, e to the power of 5x, and v as x squared. And you must know that this, as in when you say this v is equal to x squared, it can have at the maximum three derivatives, that is v1, v2 and v3. x squared, tx, 2x and then 2, and the third derivative v3 will be 0. So you stop with v2. So you must be clear of that. Okay. Then un, now what I do is I am going to apply this for this particular function x squared e to the power 5x, this Leibniz theorem. So it will be unv plus nc1 un minus v1, and the next one is I have written here d and uv for this particular problem is unv plus nc1 un minus v1 plus nc2 un minus 2 v2. I have stopped with v2 because I told you that this v2 will be equal to 2, and next differentiation, the differentiation of a constant will be 0. So further everything will be 0, that we have to stop at this place. Okay. Now it is our job to find out what is this un, what is this un minus 1, and what is this un minus 2. All these things I have got here. What is un? 5 to the power. We know that if u is here, then the nth derivative of it will be e to the power of 5x into 5. The next one will be e to the power of 5x into 5 into 5, 5 square. So like that it goes on. And the nth derivative will be what? 5 to the power of n into e to the power of 5x. And n minus 1 will be what? 5 to the power of n minus 1 into e to the power of 5x. n minus 2 will be what? 5 to the power of n minus 2 into n. So this is a simple nth derivative, n minus 1 the derivative, and n minus 2 to the derivative of the function u. So I have found all these things. I simply substitute in the places. What is un? I have substituted here. And then v is x squared. Then nc1, 5 to the power of n minus 1, e to the power of 5x, 2x. And all these things I have taken already. I have found the values. I substitute the values here, having known what is Leibniz theorem. Okay. Then after that, mere simplification. What is the highest? See here you can find that e to the 5 to the power of n minus 2 is the common factor here. So that has been taken outside. And e to the power of 5x, that is also taken outside because it is a common factor. So 5 to the power of n minus 2 e to the power of 5x is taken out. So you will be left with, if you take this 5 to the power n minus 2, here 5n, therefore this will be 5 square will be left inside, that is 525 into x square plus what is NC1? You must know what is NC1. See, NC1 will be equal to n factorial into n minus 1 factorial. Then n minus 1 factorial will go off, giving you simply n. And what is your NC1? NCC? It is NC1, NC2. NC2 will be n factorial divided by n minus 2 factorial into factorial. That is n into, see, this will be n minus 2 into, it will be like this. It is n minus 2 factorial into n minus 1 divided by n minus 2 factorial into 2 factorial. So these two will go off, giving you n into n minus 1 divided by 2 factorial. See, divided by 2 factorial, and this is how we get. See, all these things you must be familiar. Okay. Now you see that this is n into n minus 1 by factorial 2. These two and these two will get cancelled. Now taking this common 5 to the power of n minus 2 e to the power of 5x, you will be left with 25x squared plus 10. Here 1 5 will be there because you are taking 5 to the power of n minus 2. So you will be left with 1 5 here. So it is 10nx plus n into n minus 1. So what is the nth derivative of this? The nth derivative of this is this. So this is a very simple application. See, this is the mere straightforward application of Leibinitz theorem to the compound function x squared into e to the power of 5x. Okay. Now let me come to this problem. Here also I am going to, you will understand, see, some technical approach is there. That technical approach you will get when you do lot of problems and understand. Okay, understand the concept of it. Now you are given y is equal to sine to the power of minus 1 of x divided by square root of 1 minus x squared. Call this as 1 and we have to prove this result. Now I am going to apply. What is this Leibniz theorem? So Leibniz theorem has been, I have written this Leibniz theorem in order to make you understand that this will be applied to the problem. That's what I am going to do. Okay. Now y is equal to sine minus 1 of square root of 1 minus x squared. Now you find out the first derivative. You apply the u by v, that is quotient rule. Square root of 1 minus x squared into derivative of sine minus 1 of x is 1 by square root of 1 minus x squared minus sine minus 1 of x into derivative of this 1 minus x squared whole to the power of half will be equal to, so this will be half into, you know, a root of x. What is the derivative of this? See, derivative of this 1 minus x squared to the half is equal to half into 1 minus half minus 1 into minus 2x. So this is what I have done here. So whole divided by square root of 1 minus x whole square, that is nothing but your 1 minus x square. So this is nothing but these two will get cancelled, giving you 1. Minus into minus will make it as plus 1 plus x into, I deliberately write like this. See, I write like this, and you can identify that this is equal to your y. So this is your y. So I will write this as cross multiply throughout. You will get y1 into square root of 1 minus x squared plus yes, here is the whole divided by this one. This is so the whole thing is divided by 1 minus square root of 1 minus x squared. So 1 divided by square root of 1 minus x squared, x into so much, but this you identify it as y. Therefore, cross multiply, you will get y1 into, here you have got this, so this is like this. y1 into 1 divided by square root of 1 minus x squared plus x into sine minus 1 of x divided by square root of 1 minus x squared y squared. Now I told you that you can identify this as your y, so that and cross multiply you will get y1 into square root of 1 minus x square. Here this is, this one, So you see that here the square root of 1 minus x square will come. So this is square root of 1 by square of 1 minus x square plus x into sine minus 1 of x by square root of 1 minus x square whole divided by this. Or I will write this as, see here I have written here, see this is what I get. See y1 is equal to so much. You cross multiply. When you cross multiply y1 into square root of 1 minus x square is equal to these two will get cancelled, giving you 1 plus x into, see this one I will write this as, see this place is nothing but x into sine minus 1 of x by square root of 1 minus square. So this is what you will get. So in this place I will write this as sine minus 1 of this. I will identify these two will get cancelled, giving you y1 into 1 minus x square is equal to, these two will get cancelled, giving you 1, minus into minus will make it as plus, and this x is here and this I am identifying as y. So what is the ultimate result that you get for this? So this is what you get. Then you go for, now differentiate this with respect to x. Now differentiate with respect to x. When you differentiate with respect to x, this is y2 into 1 minus x square plus y1 into differentiation of minus x square is minus 2x is equal to, differentiation of 1 is 0, x into differentiation of y with respect to x is y1, xy1 plus y into differentiation of x is 1. So this is differentiating with respect to x. Then you cannot see, that is what you get here is 1 minus x square into y2 minus, this is minus 2xy1, and when it comes to the left hand side it is minus xy1, so you get minus 3xy1. Bring this to the left hand side, so minus y is equal to 0. So simplifying this, I am getting 1 minus x squared into y2 minus 3xy1. Now this is a very, very important place. Now you apply Leibinitz theorem. Now Leibinitz theorem, you treat this as your u and treat this as your v. And you must know this v will end, terminate at a point. But y2, this is u will go for nth derivative, you can find up to nth derivative. But here you see that it is minus 2x, minus 2 and stops. And likewise you will find that here x, first derivative will be there, second derivative will be 0. So what I am going to, I will take this as your u, see, take u as your y2 and v as your minus x squared. So what is that you will get here? If you find the nth derivative, already two derivatives have been found. So if you find the nth derivative, it is yn plus 2 into 1 minus x squared. See, v is 1 minus x squared. Then what is the nc1? What is the first derivative? The n minus 1, the derivative of y2. It is yn plus 1. Yn plus 2, then yn plus 1. The yn plus 1, the derivative. And differentiate this 1 minus x squared. The differentiation of 1 is 0. Differentiation of minus x squared is minus 2x plus nc2 into the, see, this is n the derivative, n minus 1 the derivative, n minus 2 the derivative means it will be yn. It will be nc2 into yn, and differentiation of minus 2x is minus 2. After that it will be 0. So it stops, it comes up to only yn plus, then it is minus 3 into, take this as your u, take take this as your v and this as your v. Now what is the nth derivative of this y1? It is yn plus 1 into x plus nc1. I am directly applying Leibinitz theorem. Okay. So x into yn plus 1 plus nc1 into this yn plus 1. The next derivative will be yn. That is un minus 1. Un minus 1 here refers to yn. And the differentiation of x is 1. So it stops. After then it won't come because the differentiation of a constant is 0. Minus, here you are left only with y. Nth derivative will be yn. So yn is equal to 0. So what is that here? What you must understand is, the first one, if you take this y2 as your u. You see, y2 as your u, v as your 1 minus x square. Differentiate this n times means find the nth derivative means already two derivatives have been found. So it will be yn plus 2. Then keep this as it is because as per Leibniz theorem this is v plus nc1. Then you want un minus 1. Un minus 1 means what? 1 less than this, that is yn plus 1. Into differentiation of minus 1 is 0, it is minus 2x. And the rest of the things follow. So this pattern will completely follow. So I apply only this Leibniz theorem, identifying what is my u and what is my v. If you have already found one derivative, then the nth derivative will be n plus 1. And the next one will be n. And the next one will be n minus 1. So like that, it gets reduced. The other one gets differentiated. Okay. So this is how we get. Then after then I collect the coefficient of yn plus 2. See, for yn plus 2, the coefficient of 1 minus x square minus, see, wherever this is, see, here it is nc1 means n, nc2 I have worked, so n into n minus 1 divided by factorial 2, and likewise I replace the nc1 means n, and I replace the nc1 and nc2 with their respective values and go for simplification. What is that you will get? 1 minus x square into yn plus 2 minus, you collect all the coefficients of yn plus 1. So yn plus 1 means here it is minus, see, take this x also outside, so you will get 2n. And here you have got what? 3x. So it is 2n plus 3. So I have collected the coefficients of, this is the coefficient of yn plus 1. See, this is the coefficient of yn plus 1. And then go for finding for collecting the coefficient of yn. So minus yn into, so here you have got yn, see, here you have got yn, here you have got yn, here you have got yn. Collect the coefficients of yn. So yn into n square minus n plus 3n plus 1. Then go for simplification. This is 1 minus x squared into yn plus 2 minus x into 2n plus 3. See, this is 2n plus 3 into yn plus 1 minus, this is 3n, this is minus n. So minus 2n. So you will get it as n squared. See, it is like this. N squared plus 2n plus 1 is equal to n plus 1 whole square. So n plus 1 whole square into yn is equal to 0. So what is the answer now? So 1 minus x squared into yn plus 2 minus x into 2n plus 3 of yn plus 1 minus n plus 1 whole square into yn is equal to 0.